Hello everyone. In this lecture, we are going to learn the isoelectronic principle and how it is applicable in our day-to-day life. Okay. So isoelectronic principle says that the molecule which are having same number of electron and same number of atom whose atomic masses are greater than that of hydrogen tends to have similar electronic structure, similar chemical properties, and heavy atom geometrics. Okay, so if you see some of the molecules are given in the bottom of this slide. These are what isoelectronic species. Okay, so alene, carbon dioxide, diazomethane, ketene, nitrous oxide, nitrile ion, isocyanic acid, azide ion, and cyanogen fluoride. These are the isoelectronic species because all of them have 3 heavy atoms and 22 electrons. Okay, so according to isoelectronic principle, they are expected to have similar chemical properties and some of the physical properties. They have similar structures also. Okay, and same number of electrons. See here, carbon dioxide, carbon disulfide, thiocyanate ion, and cyanogen bromide. These are the isoelectronic species. Okay, when these species, these are the given species. See here, between carbon dioxide and this one, when they are reacted, they are reacted. Here I have some doubt over here how they have written. Here is a plus charge and here 5 bonds to the carbon. It is somehow mistake from their side. Okay, so just try to make it this. Okay, it is just unexpected. It should be like okay. So when they react with the hydroxide ion, they give the same kind of structure or acidic functionality or carboxylic acid functionality. Here, when they are treated, these are the isoelectronic species. When they are treated with the light, they are giving here. See, this is what the species CS2. Here it is a CS2, then NH, and here these two species gives CO molecule, carbon monoxide molecule. Okay, it means what they are having somehow similar chemical or similar kind of reactivity. Okay, see here, these are the isoelectronic species having 24 valence electron. All of them shows trigonal planar structure. Here is again cyanogen fluoride. Okay, as a trimerization reaction of FCN give a following product, but CO does not undergo trimerization. Here in this case, this species undergoes a trimerization reaction. Okay, similarly, borazine is there. Similarly, benzene is there. Okay, so it undergoes trimerization. Okay, but this is isoelectronic with CO2 molecule, but CO2 does not show the trimerization reaction. So we need to be cautious over here because as it is said in the isoelectronic principle that isoelectronic species are having similar chemical properties, but certain species are there which are not having the same chemical properties. Okay, if you see here the borazine and benzene, even though they are isoelectronic, but they have different chemical properties. Okay, so if you see when benzene react with the HCl, you get BSC. Okay, so here how they mention it in a wrong way. What happened here? They are showing the benzene, and here they are taking borazine structure, skeleton of borazine. So here I can see it is a wrong matter which is shown in the book. Okay, please don't focus on this. Just remember that borazine and benzenes are having different chemical properties. Okay, so where that isoelectronic species are used. Okay, so they are used in a different practical appliances, okay, or the instruments which we are using in our day-to-day life. Okay, they are used in LEDs. Okay, they are used in a solar cells. Okay, so these are what some of the application. Okay, some of the complexes or metal. See, you can see here GAS, okay, gallium. This is what the compound, again here it is a gallium with the phosphorus, gallium with the another metal, this metal, again gallium nitride is there, okay. Then cadmium, the tellurium, okay. So here, I think, yeah, here it is a, let me check it out. Gallium is with the arsenic, okay. Gallium arsenide, we can say gallium phosphate, and then gallium arsenide, okay, gallium nitride. These are the species. Then tellurium with, copper with indium. Then gallium. This is a more complex structure over here, okay. So these are the things, okay, which are used in a solar cell or as a solar cell material, okay. So these are what the application of isoelectronic. So this is all for this lecture, and your syllabus, I would like to declare that your syllabus is over. Thank you. If any query comes, please contact me with the WhatsApp group. Okay.